So we're on to scientific notation. How many of you have used scientific notation? Yes. All right. It's a quick way to write really, really big or really, really, really small numbers, right? And scientific notation is based off of decimal movement, right? Did you go to the left? Did you go to the right? And depending on which direction you go to dictates your power of your 10. So here, if I'm going positive, that means I move to the right. So if it's a positive number, not positive number, if it's the power is positive, then I move to the right, and that's what the number is in expanded form. If the power is negative, then I move to the left, and that is the value of the number in expanded form. So let's look at some examples. All right. So typically when you are writing in scientific notation, your first factor, that C is what we call the C factor right here. That factor is between 1 and 10. Okay. So you're moving until you have a number between 1 and 10 as your C factor. So for example, here we have the distance to the sun is 93 million. And if I want to write this into scientific notation, I'm going to have to figure out how many zeros and how many spaces am I going to have to move in order for that to come to fruition. So we have 1, 2, 3, 4, 5, 6, 7. Now my C value is 9. And I had to move. I need to write 9.3. There you go, 9.3. And I had to move 7 times. So my scientific notation is 9 3/10 times 10 to the 7th. And notice that it's positive because I made something really, really big, something small. Okay. Jupiter is a gas giant composed mostly of hydrogen and having only 0.00004% water. Now, the thing here is it says percentage. So this is not just, that means that there's more zeros. Does that make sense? Because if I'm talking about the percent of something, or less zeros, I want to convert this. So I have 0.00004%. I'm going to convert it first. How do you convert from a percent to a decimal? You move the decimal place to the left or to the right? There we go. So if I want to go to percentage, I'm going to move it. Go boom, boom itself. So this equals 0.004 already. That's just a number. And then if I want to make it into scientific notation, it would have to be moved 1, 2, 3 to the negative. So I went from a percent to a decimal, from a decimal to scientific. That's I think we went the wrong way. That did not feel right. I'm tripping out here. We went the wrong way. My bad. Oh no. All right. Sorry. I'm like, what did I just say out loud? It did not feel right. To go from a percentage to a decimal. There we go. We move to the left. And I think someone said that. And I was like, no, yes. I'm so used to someone saying right first that I ignored you and told you you're wrong off the bat. Isn't that horrible? My bad. I said sorry. So I'm moving it 1, 2. So I moved it 2 to the left, which now puts me at 0, 0, 0, 0, 0. Is that 6? 4. And now I can convert to scientific, and converting it to scientific would be 1, 2, 3, 4, 5, 6, 7. 4 times 10 to the negative 7th. I was like, in my mind, these both used to have a 7 in the answer. I was like, there is no 7 anymore in my answer. This will be fun to watch back. Okay. So before you can write in scientific notation, it has to be written as a number, not as a percentage. All right. Next, you can also evaluate with scientific notation. And these are the steps to evaluate with scientific notation. 1, you're going to regroup like variables. Okay. You're going to multiply or divide non-exponent numbers. And then you're going to deal with the exponents. Remember, when you are multiplying, you add the powers. And if you're dividing, you subtract the powers. Does that ring any bells? Okay. Then you're going to write the final answer in scientific notation. So following these steps. So the first thing is to combine, rewrite using associative property. So first, we're going to rewrite this. Factors with no power together, factors with powers together, basically. So it becomes 3 times 2 and 10 to the 3rd times 10 to the 4. Does that make sense? Yeah, you just call it the 4th. After cube, we just say 4. And then you're going to evaluate each one. So we have 6 times 10. And again, you're adding your powers. So 3 plus 4 is 7. And you've evaluated. So 3 times 10 to the 3rd times 2 times 10 to the 4 would equal 6 times 10 to the 7th. Okay, and this works because multiplication is commutative and has commutative and associative powers. Meaning I can rearrange the numbers and the value, the product won't change. The value of the product won't change. Questions about multiplying scientific notation? We're good with multiplying scientific notation? All right. With that being said, I would like you to take a moment and try to multiply this scientific notation. All right, so let's check and see how you did. So when you multiplied, you rearranged and you had 5 times 6 times 10 to the negative 3 times 10 to the 5th, which gives you 30 times 10 to the 2nd. Now, this isn't scientific notation because your C value in between 1 and 10. No. So it will be result in 3 times 10 to the 3rd.
Why 10 to the 3rd?
Because 30 has to be between 1 and 10. So this is the same thing as writing 3 times 10 times 10 to the 2. Okay. All right, so we will pick up on division tomorrow, and yeah.